Building production-grade generative AI applications requires more than just calling an LLM API. You need a well-architected project structure that separates concerns, enables testing, and scales from prototype to production. Let me walk you through a battle-tested structure that professional AI teams use. At the root level, you have four essential directories: config for configuration, data for storage, source code and SRC, and tests for validation, plus deployment files, git-ignore, Dockerfile, Docker Compose, and requirements, because modern AI projects ship in containers. The config directory contains your project configuration files. Model_config.yaml defines your model settings and API keys, which LLM you're using, temperature settings, token limits. Logging_config.yaml sets up your logging infrastructure, critical for debugging when things go wrong, and they always do in production. The data directory stores all project data with three key subdirectories. Cache holds cached and processed data because you don't want to reprocess the same documents or regenerate the same embeddings repeatedly. Embeddings stores your vector embeddings, the numerical representations of text that enable semantic search, and VectorDB contains your vector database files. This is where your knowledge base actually lives. Now the source directory. This is where the real work happens. It's organized into 6 specialized modules, each handling a distinct aspect of your AI pipeline. The core module manages LLM abstraction and integrations. Base_LLM.py provides a common interface for all LLMs. Whether you're using GPT, Claude, or local models, your application code stays the same. GPTClient.py handles OpenAI GPT integration. ClaudeClient.py manages Anthropic Claude integration. ModelLimits.py tracks rate limits and token budgets to prevent API cost surprises, and ModelFactory.py implements the factory pattern for model selection, dynamically choosing the right LLM based on task requirements. The Prompts module handles prompt design utilities. Templates.py stores your prompt templates because good prompts are assets you refine over time, not strings scattered throughout your code. Chain.py enables multi-step prompt chaining, where one LLM calls output feeds into the next, creating sophisticated reasoning workflows. The RAG module, Retrieval Augmented Generation, is your knowledge integration layer. Embedder.py handles embedding creation, converting text into vectors. Encoder.py manages document search, finding relevant content in your knowledge base. Vector.cre wraps your vector database with a clean API. And Indexer.py orchestrates document indexing, the pipeline that makes your documents searchable. The processing module runs your data preparation pipeline. Chunking.py splits documents into optimal chunks, not too big to lose context, not too small to lose meaning. Tokenizer.py provides tokenization utilities, breaking text into tokens the LLM understands. Cleanup.py handles data cleaning tasks, removing noise, normalizing formats, preparing raw data for embedding. The Inference module manages model execution flow. Inference.engine.py is your inference engine, the runtime that actually calls the LLM and manages the generation process. ResponseParser.py handles output formatting, converting raw LLM responses into structured data your application can use. The Tests directory ensures everything works. Unit tests validate function-level behavior. TestLLMClients.py verifies each LLM integration works correctly. TestPrompts.py confirms your prompt templates render properly. Integration tests validate end-to-end workflows. TestLLMintegration.py ensures LLM clients work in realistic scenarios, and TestAPIintegration.py confirms your APIs integrate correctly. The Scripts directory contains your operational tooling. Setup.env.sh configures your environment variables and dependencies. Dockerfile defines your container image, ensuring consistent deployment across environments. DockerCompose.yaml orchestrates multiple services, your application, vector database, monitoring tools. Requirements.txt lists all Python packages your project depends on. This structure embodies 4 critical principles. First, separation of concerns. Core LLM logic is isolated from RAG, which is separate from data processing. You can modify one without breaking others. Second, testability. Unit and integration tests ensure reliability and catch regressions early. Third, configurability. All settings live in config files, not hard-coded. Change models, adjust parameters, modify logging without touching code. Fourth, deployment ready. Docker files and Compose files mean consistent environments from development through production. Why this matters? Most generative AI projects start as notebooks and scripts. They work for demos, but collapse when you need reliability, scale, or collaboration. This structure scales from one developer to a team, from prototype to production, from local development to cloud deployment. It's the foundation that lets you build AI applications that actually ship